Hey, welcome everyone into the NGK Tech Garage. Today, just as the title suggests, we are looking at a power window issue on a 2003 Infiniti G35. Now this one comes with a little bit of a twist, but you're gonna have to wait till the end of the video for that twist. We're gonna start off today going through what I would call a pretty typical modern power window diagnostic. Now this car is a 2003, it's 15 years old already, but a little bit of a unique thing with this car is the switches aren't like a standard window switch. They are actually a smart switch or a module switch, or they have a small IC or a small computer inside of the switch, okay? So the diagnostics are a little bit different here. So we're gonna walk through a power window diagnostics, and then at the end we're gonna twist it just a little bit. It's got to do with the story and finding the actual root cause of our problem. So the customer came to me with the right front window in-op on here, okay? Vehicle's in, start looking at it, and first thing, like always with any diagnosis, is we verify the complaint. So driver's window switch, I'll try it right here. Doesn't work, up or down, neither one function. Passenger's window switch is the same way. Now one thing that I want to note at the beginning of a diagnosis like this, especially on cars that have a frameless window like this right here, there's no frame coming around the glass, right? Other coupes have this, Mustangs, Camaros, there's way more out there, but this Infiniti does have a frameless window design. So when I close this door right here, you would see the window close slightly. As soon as I touch the door handle and open it, it drops down slightly, maybe a ½ inch or so it looks like, judging by the molding right here, okay? This is important. If you're running into a power window issue where the window is not working, it's not moving at all, the switch might not be working, the motor might not be working, who knows what the problem is at that point, but just know that if this window doesn't move properly, it's possible that it could be stuck in the frame here. So you try to open the door and the window is stuck in the frame, or if the window is all the way up in the all the way up position and you slam that door closed, it could hit the frame and shatter the window, okay? So keep that in mind when you're working with frameless windows. All right, so let's get into the diag. We've already verified the complaint. We have an in-op passenger side window. Let's go ahead and take a look at our wiring diagram on here. So we'll start off with the main switch diagram. We have our smart switch here. This is our driver's side switch. We have a body control module involved, and then we have some fuses here feeding the BCM. So we have a 10 amp, a 10 amp, and a 50 amp all feeding into the BCM at different times. And then out of the BCM for the Windows circuit, we have a power window serial link. We have a power window power supply wrap, or retained accessory power is usually what that means. That's where you shut the key off and pull it out of the ignition. You're still able to move your windows up and down as long as you don't open the door. Then we have our main power supply battery, and we have a ground circuit. Those feed down. We have splices here. I'm assuming these splices probably go off to the passenger side, and they also feed into our driver's side. And here's that CPU internal to the window switch, okay? So things are a little bit different on this vehicle. Now we do have a serial link line, which could mean some sort of data, some sort of electronics, some sort of communication happening from our window switch to our BCM, or maybe to our other window switch. So I did have the scan tool out here. It's all hooked up. Went into body, went into codes, went into data, went into special functions, went into actuation tests, and I had nothing pertaining to either of the Windows switches. So that's unfortunate. This tool was unable to do it. I don't know, maybe a Nissan factory scan tool or the Infiniti factory scan tool might be able to give you some data out of the power window, but like many of you guys out there, I don't have that tool at my disposal. We use the Snap-on tool here amongst many others. But we don't have the Infiniti one. So if you have an Infiniti tool, it'd be interesting to know if you can pull any data out of this Windows switch or BCM related to the Windows. But we're going to address this today without that information, okay? So let's follow into our passenger side window diagram here. And this is our main window switch. If we go down one more, we'll run into our passenger side front. They call it a sub switch, but this is going to be our passenger side switch. So again, we have a battery positive coming in from the BCM. We have that wrap or retained accessory power from the BCM, and then we have that serial link. And then from our switch, we have our 2 wires that reverse polarity. These are going to run our motor up and down. We have an encoder, and then we have a limit switch built in there as well, and then we also have a ground leg coming out of that switch. So this tells me that not only do we have a smart switch, but we have a motor that has some intelligence to it as well. And that might have to do with the fact that the motor can open and close that little bit. So we have a lot of different things to check here. So what do we need to figure all this out? Well, there's a couple tools that are going to be really handy. A voltmeter of some kind, so you can check for powers and grounds. A test light, so we can put a small load on the circuit. Now, a window motor is probably going to pull a lot more than this test light, but we can put a small load on the circuit. I got a couple of fused jumper wires, and then the pinout kit, so we can pin out our connector without damaging our terminals. So we have a diagram. What are the things that we're going to do? What are we going to check first? We want to attack this in an intelligent manner. So what I like to do is, first of all, we'll take a quick copy of this. If you guys don't use GreenShot, it's a pretty cool program that allows you to basically draw on your stuff right away. So it's a free program you can download called GreenShot. Check it out if you haven't. But what we're going to do first is, we know that we should have power coming in here, right? And we should probably have power coming in there. And this, you know, we're kind of questioning what the serial link might be. That's probably some sort of data control. Maybe affects it, maybe it doesn't. But since we don't have a clear, concise answer on what this is right now, let's leave that out of our testing for the moment. And then let's grab, we know that we should have ground. Uh-oh. There it goes. We know that we should have ground on our ground pin, right? So we can check for battery voltage. Oh, let's turn you back red. So we can check for battery voltage on these pins. We can check for ground here. We could put our test light across these two and we can verify. And then what we also want to do is some sort of test to verify that our window motor works. Now if we're fed power and ground to our switch, we can use these and we can basically jumper our switch. So what I'm saying is we can take our power wire and we can go from pin 6 with our fused jumper wire, and we can head on over here to pin 5, okay? And then if we do that again, if we take our ground wire here and we run that over to pin 4 of our connector, again, all we're doing now is bypassing our switch. We should be able to move this motor up and down. And then if we swap them, vice versa, now we're, let's keep red up there just so it's easy enough. Now we're red on pin 4, there, and we're black on pin 5. The motor should go in the other direction. But just be careful with this. Again, with frameless windows, you run that motor all the way to the top, you could potentially break the window, okay? So that's pretty much the testing that we're going to start with here. So why don't we head over to the passenger side and see what we've got going on. All right, so let's start with some power checks. So let's see if this will sit in here, maybe. Maybe you guys can see that? All right, nice. Now I do have the key turned on. Let's go ahead and see if we can get this switch out of here. That wasn't so bad. And again, we have no operation of our window. So let's go ahead and let's disconnect our connector. Should have grabbed a screwdriver. Okay. So like I said in our diagram, we're looking at the power and ground wire coming in. So we're looking here at this black wire and this white wire, okay? So we should have, as long as the key is on, we should have power on white. Actually, let's grab some pins here. That way we don't possibly wreck our connector in any way. Probably about this size. And we'll just pin out the white and black wire on here. That's going to be our power and ground fed into the switch. So when I connect the meter to this, we should see battery voltage. Beautiful, 12.31 volts, so our battery's slightly discharged, but we're at just under battery voltage, okay? So that is wonderful. Now, like I had talked about, we can jump this connector and see if we can make our window go down. So let's get this guy out of the way. Now I have some fused jumper wires here, and all we're going to do is we're going to act like the switch. So all the switch does is make a contact between a power point and the motor and a ground point and the motor. So we'll start with, we'll go white, which is power, and we'll run that to the green wire, like so, and then we'll run ground, going this side of the connector. We'll run ground to our blue wire. Let's see what happens here. All right, our motor goes all the way down. Now, if we swap these around and we run our ground to our green wire and our power to our blue wire, the motor should go back up. So we'll just disconnect on this side of the connector. We'll go now here to green. There we go. So our motor goes all the way back up, and just note that it stops up here at the top. So it's tight against my molding right here on the body. So this motor, or this window, is all the way in the upmost position. So if I close this door now, we could run into an issue with the glass hitting the body, okay? Just take note on that we gotta be really, really careful. So now this is not an intermittent problem, this is a consistent problem. We know that we have power and ground being fed to this switch. We know that our motor is functioning. It's time for a switch, right? I mean, a couple quick tests. There are a few other things that could possibly maybe be an issue, but it really looks like we have a switch problem, right? We have no control over this side. We have power and ground, and our motor is functioning. So the customer was nice enough to bring a switch along. So we'll go ahead, plug this switch in, and let's see what happens. And there it goes down. There it goes back up. And down. And back up. Working fine. Alrighty. So this seems to have fixed it. And it looks like there needs to be some sort of relearn done for this window, because when I brought it up to the top, it did come back down this low. So that's potentially an issue that would need a relearn involved, but nothing too serious on here. So this car is fixed now, right? We put a window switch in. Everything is back to normal. Or is it? All right, so this is where the twist in the diag comes in, right? So I call the customer up, tell him that he needs a window switch, and that's when I hear the rest of the story. So he tells me that when he originally had his problem, his passenger side window wasn't rolling down, wasn't rolling up, wasn't doing anything. He went out and found on a forum or wherever that he should put a window motor in it. So he's a pretty handy guy, went out, bought himself a window motor, slapped it in there, and still no go on the window. Still wouldn't go up, still wouldn't go down. So the next thing on the forum said replace a window switch. So he went out to the store, bought himself a window switch, put it in, and his window worked. He was happy. He was feeling great. He fixed it himself. Problem comes 2 weeks later. Using the window, working great, and then it stopped working about 2 weeks into it. Now this isn't an intermittent problem. It didn't stop working and then start back up and then stop and start back up. It didn't do that at all. When it stopped working, and that's where I got the car. That's where we started today, but I didn't get that information up front. It's, the usual, hey, my window's not working, can you fix it? Okay, so if this was the case, if I didn't get the rest of the story from this customer, if I put a window switch in here, this guy'd be back in my shop in, 2 weeks? With a complaint. So you put another window switch in, you put another window switch in, you put another window switch in. At what point Is it not a window switch issue? You know, maybe the window switch wasn't the failure in the first place. How often do we see cause and effect failures, right? The cause for the failure was something and it affected something else. Spark plugs taking out ignition coils, blower motors themselves taking out blower motor resistors. You know, we see this kind of stuff all the time. Is it possible that our window motor took out our original switch and then with a new motor, a new switch, everybody's happy again? But what if our new motor isn't a good motor? How do we prove that? How do I prove that to the customer that it's not just a switch issue? Yes, this switch is not functioning, your new switch is not functioning, but was it caused by something else taking it out? I don't think that we have a switch issue here. And so my goal here was to go out and prove it, and that's where the twist comes in. So what can we do? Well, we're dealing with an electric motor, right? We're dealing with something that we deal with all the time. Every time we start up our vehicle, every time we are running down the road, we have an electric motor in the fuel tank pumping gas for us, right? Pumping it up to our fuel rail. How many of you guys out there have current ramped a fuel pump before? You're looking at an electric motor. Power windows really aren't any different. Yeah, our control on here is different. Yeah, they are bidirectional or they swap polarity to move up or down, but they're still an electric motor and we can still scope amperage on them. So I have the scope out. I have 2 amp clamps out. Let's start them off on the 20 amp range. And what we're going to do is we're going to scope each window and see what happens. Now what's nice about window circuits is usually you can get a known good pattern right away, right? We have a functional driver's side window. We have a questionable passenger side window. So we hook this clamp up, driver's side, passenger side, and we can compare the two. So let's get these all hooked up. Again, I'm on the 20 amp mode. We'll hook this one into channel A. We'll run channel A or our blue trace for our driver's door. And then we'll run channel B, our red trace, for our passenger side door. So let's go ahead and pop off of our switch plate here. And according to our wiring diagram, our green wire is also for this side. They both use a separate green wire between the switch and the motor. So we'll put our clamp on there, we'll zero it out, and let's go ahead and set up our scope real quick before I go over to the other side and set that one up. So we're using a 60 amp current clamp on the 20 amp mode. Let's go ahead and change our range here. Let's go -5 to 20, should probably work. And we'll do the same thing with channel B. -5 to 20 amps. Okay, so they're both set up. Let's go set up the other clamp real quick. And now, because we're using a motor that can reverse polarity, our current can flow in different directions. So for starters here, what I'm doing is I'm making sure my clamps are in the same direction. So both of my clamps are currently with the writing on the clamp facing away from the switch. So they're both going to read current in the same direction. That way we get a similar looking pattern for both, okay? If we put them, one clamp facing this way and the other clamp this way, the current is going to go in opposite directions. So right now we have both clamps facing the same way. Let's change up our time here. We're at 5 milliseconds per division. Let's go up to, we can always zoom in. Let's go 5 seconds. Let's turn up our sample rate a little bit there. All right, so what we're going to do now is I'm going to roll both windows down here with the master switch with our new switch installed on the passenger side. And let's see what happens. All right, windows down. All right, they're at the bottom. And windows back up. All right, now I'm going to quickly I'm going to swap them around, our clamps around. So now our writing is facing the switch. Because now we'll capture our polarity in the other direction. Now I'm sure I could have set up the scope different on here, but this is just showing you that we'll see our amperage in the other direction. So now both windows are up. We'll wait for the screen to refresh, and we'll go down this time, and we'll see our amperage go up. So you can see our different polarities of our motor. And now when I bring the windows back up, you can see that we're down below. So it all depends on how you're reading your amperage. As long as you know that the current clamp is going to read it in different directions, that's all you really need to know here what we're really looking at is we're looking very closely at the amperage itself. So let's go ahead and pause this. So here's our window motor going down. And if we go back one page, here's our window motor going up. So the first thing that I notice on here is, we can call it hash, we can call it noise, we can call it whatever we want to call it. The red trace is significantly fatter on the screen, right? We're seeing a lot more, it would be referred to as amplitude on our screen. So what that's telling me is at the peak, at the bottom here, we're at 5.7 amps on our red trace. Let's get the blue one out of the way for a second. And at the top of our trace, in that same spot towards the end here, we have almost a 4.5 amp swing on this motor, meaning we're running almost like an AC signal, a 4.5 amp amplitude on there. Now let's put our blue trace back where it belongs, and let's do the same thing for the blue trace. So at the end of the circuit here, we're looking at about 1.3 amps of amplitude or change on this motor. Again, the blue side, drivers, red side, passengers, okay? So this is already looking a little sketchy. Let's go look at where I swapped the clamps over. Now we're going downwards. Look at this. Look at the change here. Driver's side is blue, passenger side is red. Let's go ahead and let's zoom in on this one a little bit. Let's get our cursors out of the way for a moment. We'll just zoom in on this section. So look at our amplitude difference here, and then look at our current difference. So let's start with current. Our red trace for the motor to go down on the passenger side peaks here at roughly 8 amps. It's taking 8 amps to run that motor down into the door, which is usually counterintuitive, right? It should be easier for the motor to roll the window down than it is to bring it up. There's really not as much weight involved. There's gravity. It should be easier to go down than it is up, and that's what we're seeing here. Our amperage is lower on the driver's side to go down than it was to go up. So we're seeing 8 amps there for going down, and our driver's side is taking about 3 amps to go down. So a 5 amp difference for our windows to go down into their tracks. Now, if you're noticing very slight differences, you have to remember that there could be wear components in the regulator assembly of the window, in the tracks on the sides. Typically, from a comparative process here, we usually see the driver's side working a little bit harder than the passenger side because there could be things wearing out, getting sticky, getting gummed up. The regulator might be a little bit dry. It might not be as lubed up as the passenger side. Typically, the driver's side does have to work a little bit harder because it gets used a lot more. But our current here is, I would say, is definitely a problem. We have a significant higher current. But let's go in even further. And those of you who have scoped fuel pumps before know where I'm going here. So when we're looking at a fuel pump, we like to see a relatively consistent pattern, kind of a low amplitude for amperage up and down. And that's kind of what we're seeing here with our blue trace. It looks pretty good. This is what we would be looking for with our blue trace for a known good condition. You look at that red trace, it is all over the place, right? We are seeing huge amperage swings. We are seeing a dirty, messy motor. It is not a good motor on here. So how many of you are actually using a lab scope and an amp clamp and scoping out the current for each window motor when you're doing a diagnosis like this? You know, if we chose not to do it at this point, if we would have stopped once we diagnosed the switch is bad, it's failed. Once we diagnosed that switch is bad, put a new one in, gave the vehicle back to the customer, ran it out the door, customer would have been happy, right? The window works, it was working over there, we had it functioning up and down with this new switch, it was great. But what happens after 2 weeks when the customer's back? Because it fails again. That's what happened with this one. The owner put in a window motor, put in a window switch, and then 2 weeks later, the switch has failed again. The problem here is the cause and effect, right? Just like a blower motor and a blower motor resistor, it's very rarely the resistor's fault. It's taken out by the blower motor. Well, same thing here. This window motor has taken out our switch. Now, he put himself a nice high quality switch in there, one of our switches, But what he didn't do was he didn't do a high quality motor. He went out and shopped on price for his motor and found a very cheap motor in comparison to a high quality part. It was significantly cheaper. And it's directly reflected in the current that that motor draws. It is a dirty part that is going into a computerized circuit. The window switch is computerized. Now, would this motor affect an older style switch? Probably not nearly as much, but we know we have a computerized circuit that doesn't like noise like this, and it doesn't like the excessive current, especially on the downward swing of this motor. So we do have an issue with this motor. Now, unfortunately, our customer here has chosen not to fix this car. He's chosen not to replace the window motor on the passenger side. He tells me that he's not going to be using the passenger side window. Now, if he chooses someday in the future that he wants to replace that with a good quality part, then of course we'll do a part 2 to this video and we'll show you the differences in the current ramp for that new motor. That will show that it's not going to kill our switch. It's going to be a good running motor on there. So I hope you guys enjoyed this. I really hope you take something out of this lesson, whether it's scoping or jumping the switch to run the motor up and down, something out of this lesson to help you to diagnose your next window circuit issue. So if you did like the video, please give us that thumbs up. Click that subscribe button down there. Click that little bell icon. That way you get a notification anytime we have a new video out. So I thank you again for watching and joining us today. And we'll see you next time in the NGK Tech Garage. Thank you.